6 linear systems, our essential question is how can you find and represent solutions of systems of linear equations and inequalities? Okay, our table of contents. Solve a system of linear equations. Okay, so solving a system of linear equations, a system of linear equations is a set of 2 or more equations using the same variables. The solution of a system of linear equation is the set of all ordered coordinates that simultaneously make an equation in the system true. So if you graph it, it's where the lines cross. So what is the solution of the system of linear equations x plus 2y equals 4 and x minus 2y equals 4? So I can put the equations in slope-intercept form, okay? And then I can graph each of those lines and see where they touch, okay? In this case, that's my solution, okay? If you have the same slope, then they are parallel lines. So like 1/2 x plus 2 and 1/2 x plus 3 would be parallel lines. And if they have the opposite reciprocal slope, they are perpendicular. So 1/2 x and -2. Okay. I can also solve algebraically, okay, by lining it up and solving for one specific variable. In this case, I solved for x since both x's were by themselves. And then I set them equal to each other, and then I solve for y. Okay. In this case, y equals 0. Once I have y, then I substitute it back into one of my equations. It doesn't matter which equation you choose. You can use either, or you can check it in both. Okay, so when I substitute it back in, I get x equals 4. And you should get the same answer regardless of which equation you set it in. Right. Solve a system of linear inequalities. Solving a system of linear inequalities. So example, Malcolm earns $25 per hour mowing lawns and $8 per hour walking dogs. His goal is to earn at least $250 each week, but he can work a maximum of 15 hours per week. He must spend at least 2 hours per week walking his neighbor's dogs. How many hours should Malcolm work at each job so that he can meet his goals? So we're actually going to create a set of inequalities. So we're going to decide on variables. I'm going to use x and y. So x is going to determine how many hours Malcolm can mow lawns, and y is going to determine the hours Malcolm can walk dogs. You, of course, can use different variables, okay? So then I'm going to determine my inequalities. So 25x plus 8y is greater than or equal to 250. Okay, it's $25 per hour of mowing lawns. He makes $8 an hour walking the dogs. And he wants to earn at least $250. So he wants to make that or more than. Okay. Then I have x plus y is less than or equal to 15 because he can't work more than 15 hours a week. So the number of hours he mows lawns plus the number of hours he walks dogs is less than or equal to 15. Okay. Y is greater than or equal to 2. It also told me that he has to walk dogs for at least 2 hours. Next thing I can do is graph and shade the functions. So the first one, 25x plus 8y, I changed into slope-intercept form to make it easier to graph. And I did the same with the x plus y is less than or equal to 15. Okay. And then y is greater than 2. And wherever all the shading crosses, that's going to be my solution. So in this case, my solution is in this purple-green triangle area. Okay. So one solution could be that Malcolm mowed lawns for 10 hours and walked dogs for 5 hours. Okay. So you can use any of these solutions in here. Any of them would be correct solutions. So 1, 2, 3. So that's the 10. You could do 10 and 3, 10 and 4, 10 and 5, 10 and 6. Okay. So any of those would be solutions you could do. Solve a system of equation in 3 variables. So what is the solution of this system? 2x plus y minus z equals negative 10, negative x plus 2y plus z equals 3, and x plus 2y plus 3z equals 13. I want to assign each of my original 3 equations with a letter. Okay. Then I can work on manipulating those equations so I can get rid of one of the variables. I want to isolate one of the variables. In this case, right now we're working on getting rid of z. Okay. So this first equation, 2x plus y minus z equals negative 10, is equation A. Negative x plus 2y plus z equals 3 is equation B. X plus 2y plus 3z equals 13 is equation C. So in this case, I recognized that A plus B would allow me to get rid of a variable. Okay. So in this case, I've taken A plus B and I've made it equivalent to a new equation, D. Okay, so I'm adding these together. 2x plus negative x equals 1x. Y plus 2y is 3y. And then negative z plus z is 0. It's nothing. Okay. And negative 10 plus 3 is negative 7. Okay, so now I have that equation. I still want to do something so I can manipulate another equation so I can get z gone again. Okay. So in this case, I'm going to take my B equation and I'm going to multiply it by negative 3. Okay. What this is going to do is it's going to give me a new equation E. Okay. So I multiplied through negative 3. So negative 3 times negative x, negative 3 times 2y, and negative 3 times z, and negative 3 times 3. So I get 3x minus 6y minus 3z equals negative 9. Okay. Now that I have that new equation, I can take C, my original equation, plus E, my new equation that I just created, to get me another new equation, F. Okay. But what I'm doing is I'm, again, getting rid of z's. Okay. X plus 3x is 4x. 2y minus 6y is negative 4y. 3z minus 3z is 0. Okay. And then 13 minus 9 gives me 4. Then what I'm going to do is I'm going to take D, the equation that I had last time, right? This very ending, x plus 3y equals negative 7. And I want to make it look, or try to get it to look like my equation F. So I'm going to multiply everything in D by negative 4. That's going to help me get rid of my x's eventually. So when I do that, negative 4 times x gives me negative 4x minus 12y equals 28. Okay, that's G. Now I'm going to take G and multiply it by F. Or I'm going to add them together. That's going to give me a new equation, H, but it's going to allow me to get rid of another variable. Okay. When I do that, negative 4x plus 4x gives me nothing. It cancels the x's out. Negative 12 plus negative 4y is negative 16y. 28 plus 4 is 32. Now I can solve for y because I have just one variable. So I'm going to divide both sides by negative 16. That gives me y equals negative 2. Now I'm going to take what I know for y, and I'm going to substitute it back into one of my equations. Now it makes sense to substitute it into either D or F, okay? Because again, I have 2 variables in that as opposed to 3 variables, okay? So in this case, I put it back into D. You can put it into F, that is fine. It'll give you the same solution set, okay? So when I put negative 2 in, I have x plus 3 times negative 2 equals negative 7, which gives me x minus 6 equals negative 7. I add 6 to both sides. I get x equals negative 1. Okay. Now that I have negative 1, I'm going to substitute both the x and the y into one of my 3 original equations. Again, you can use A, B, or C. I chose to use A. Okay. When I do that, I have 2 times negative 1 plus negative 2 minus z equals negative 10. Negative 2 plus negative 2, of course, is negative 4. Minus z equals negative 10. I add 4 to both sides, so I get negative z equals negative 6. And then you can either multiply by negative 1 or you can divide by negative 1, but you'll get an answer of z equals 6. Okay. So in the end, my solution is going to be my x value, my y value, and my z value. So negative 1, negative 2, 6, okay, is my solution. All right, write a system of equations as a matrix. So a matrix is a rectangular array of values. To use a matrix to represent a linear system of equations, the equations must first be written in standard form. Standard form is ax plus by equals c, okay? Or dx plus ey equals f, or ax plus by plus cz equals d. So it depends on how many variables you have, okay? A coefficient matrix shows the coefficients of the variables in the system of equations. So if this is my equation that I'm using, 2x plus 3y equals 1, 4x minus 2y equals 10, okay, I'm taking the coefficients from the x's and the y's, okay? So 2, 4 are the ones that are aligned with the x's. They go in one column. And then 3, negative 2, they go in the second column. An augmented matrix shows all coefficients and constants in the system of equations, and a dashed line separates the variable terms from the constant terms. So in this case, I had my 2, 4, 3, and negative 2, and then from my equations, right, I had equals 1 and equals 10. Those become my constants. Those are my constants, so they're what goes behind the dotted line, okay? The dimensions of a matrix is R times C, or the rows times the columns, okay? Rows go horizontally, columns are vertical, okay? So in this case, it is a 2 by 3 matrix, because I have 2 rows and 3 columns. So how can you represent x plus 2y equals 2, x minus y plus 3z equals 5, and 2x plus y minus 4z equals 10 using a matrix? So the first step I have is writing each equation in standard form and including all 3 variables in all 3 equations. So if you notice that first equation, x plus 2y, there is no z variable. I'm going to add it in, okay? But I can do that by saying 0 z, because there's no z's there, okay? So I rewrite all of them, okay? Notice I have my x values, there's a coefficient in front of each of them, a coefficient in front of each of my y values, and a coefficient in front of each of my z values. And then of course my constants at the end. So all I have to do then is write the coefficients using the matrix. So I had 1, 1, and 2. 1, 1, and 2 becomes my first column. 2, negative 1, 1 becomes my second column. 0, 3, negative 4 becomes my third column. And should say 2, 5, and 10 becomes my final column. Relating systems of equations and matrices. Example, an algebra teacher creates the matrix shown to describe an exam, where X represents the number of 2-point questions and Y shows the number of 5-point questions. Write the corresponding system of equations. What does each equation represent? So I have 1, 1, 19, 2, 5, 50. So in this case, I have 1x plus 1y equals 19, and then 2x plus 5y equals 50. So that's my set of equations. X represents the number of 2-point questions and Y represents the number of 5-point questions. So if I have X, Y, right, the number of 2-point questions plus the number of 5-point questions, there are 19 questions total. 2x plus 5y equals 50. The 2-point questions are worth 2 points apiece. The 5-point questions are worth 5 points apiece. And then there are 50 points total on the exam. I want to know, what does the matrix 1, 0, 0, 1, 15, 4 mean in terms of this context? Since we know that X represents the number of 2-point questions and Y represents the number of 5-point questions, we can see that there are 15 2-point questions and 4 5-point questions. You can always check and make sure that those actually satisfy the original two equations that you created. So if I put 1 times 15 plus 1 times 4, do I get 19? 15 plus 4 does equal 19. And then 2 times 15 plus 5 times 4 equals 50. 2 times 15 is 30. 5 times 4 is 20. 30 plus 20 does equal 50. So whenever possible, graph when possible and look for where lines intersect. With inequalities, you want to graph and look for where shaded regions overlap. Okay, and then when you're dealing with matrices, you're just looking at the coefficients and the constants. And that is the end of lesson 6.